Hello everyone, did you know that 30% of ordinary matter like hydrogen or helium atoms making up our body, we didn't know where they are, but finally they are found. Today I'm going to introduce a paper that solved the missing baryon problem.
Mysteries of the universe.
This is a total energy budget of the universe, and then 70% of the total energy budget of the universe is so-called dark energy, which we don't know what it is. And then remaining 26% is dark matter, which we know they exist, but we don't know what it is. But the last piece, 4.9% of ordinary matter, or baryons, these are the ordinary matters like hydrogen or helium or carbon, oxygen that make up our body or planets or stars. Those ordinary matter, at least we know these are ordinary matter, and then we know precisely they are 4.9% from Big Bang theory and then cosmic microwave observation. We know precisely these are 4.9%. This is the so-called triumph of the Big Bang theory. However, among those 4.9%, we know roughly 70% of these ordinary matters where they are. Some are stars that we know, or H1 gas, this is a neutral hydrogen gas, we can detect them with radio telescopes, and also hot plasma gas, we can detect them with X-ray telescopes. These are blue areas. Oh, by the way, more than 75% of these elements are hydrogen because of the Big Bang. However, this black part is missing. About 30% of these 4.9% of ordinary matter, we don't know where they are. This is the so-called missing baryon problem. Well, there are a lot of mysteries in the universe. We don't know what is dark energy, we don't know what is dark matter. Remaining 4.9% of all point matter we thought we know, but 30% of this ordinary matter we don't know where it is. We know that most of them are hydrogen because more than 35% of these ordinary matters are hydrogen, but we don't know where they are. But we astronomers are not so totally stupid. We have some idea. So if you do a computer simulation of the formation of the universe, then we see these galaxy clusters from these bright spots are galaxy clusters that's made of thousands of galaxies. These we can observe. But then between these galaxy clusters we notice there are some filaments connecting these galaxy clusters. These are low temperature, so we cannot detect with X-ray telescope. But if we do the simulation, we see it in a computer. So astronomers and researchers have guessed that these missing baryons, missing ordinary matters, may be in these filaments. However, there's a problem. These filaments are low density and then lower temperature, so we cannot detect them with X-ray telescope. At least individually we cannot. Here's an example. This is an X-ray picture of galaxy clusters, two galaxy clusters, and then you see two bright spots in each of the picture. These are galaxy clusters, and then these galaxy clusters are filled with hot plasma gas at temperatures about 100,000 Kelvin. So they're bright in X-ray, so we can detect them with X-ray telescope. However, there's nothing detected with X-ray telescope in between them. According to the simulation, there may be a filament connecting these galaxy clusters, but we cannot detect them with an X-ray telescope because they are low temperature and low density. So, how can we detect missing ordinary matter? Here comes a paper written by my friend that I introduced today. They first time detected hydrogen gas using X-ray telescope from these filaments. An innovative idea of them was they stacked many filaments. So those filaments are faint and low temperature. Individually we cannot detect them. So they found 15,000 filaments and they stacked together. for an individual images, the signal is too low or too faint, so they cannot detect it. But by stacking 15,000 filaments, the signals, as you stack more and more, signal gets stronger and stronger little by little, and then finally, after stacking 15,000 filaments, they detected it. If you look at this figure, the cyan part is a noise part, and then black line is the detection from their data. And as you can see, these black lines are above the noise, right? So this is the detection of X-ray gas in these filaments using an X-ray telescope. They also measure the temperature of these gas in the filaments, and then they found temperatures about 10,000 Kelvin. You might think, oh, I said low temperature, but 10,000 Kelvin is very high temperature. Yes, it is. But compared to galaxy clusters, very bright in X-ray, are about 100,000 Kelvin. So that's why they are bright in X-ray images. So compared to that, the temperature of 10,000 is 1/10, so it's much lower temperature. So that's why individually they cannot be detected with an X-ray telescope. My friend has found this missing part of the ordinary matter in filaments, hydrogen gas in filaments. And then he told newspapers that the missing baryon problem is solved. How cool it is. I want to say something like this once in a lifetime. Well, I believe this is very nice paper and very nice research work. Okay, today I talked about the missing baryon problem and then how the problem was solved. If you like the video, please like it and then subscribe to my channel. As usual, questions and comments are welcome down below. Okay, see you next time.